Section 6.2, example 2, graphing a shift on an exponential function. So graph f of x is equal to x plus 1 minus 3. State domain, range, and asymptote. Let's do a little recap really quick. So back in, I believe it was chapter 2, possibly chapter 3, we had our transformation of functions. So what we had, let's look at a quadratic. So we had a times x minus h squared plus k. Directly next to our input was our horizontal shift. So horizontal shift. K was our vertical shift. A did a number of things. So it was our stretches and reflections. So stretches and reflections. So here in quadratic functions, it's very, very similar. So we have a times, this time is our base. We still have our x minus h plus k way out here. The one closest to our input is going to be our horizontal stretch. So we could call this one our horizontal stretch. This one is still our vertical stretch. A is still our, I'm sorry, I said stretch, vertical shift. A is our horizontal and vertical stretches, compressions. It does our reflections as well about the x-axis. B is the only new thing that we're talking about here. B is going to be our base. So the base is going to tell us how quickly we take off or how slowly we take off. So it's going to show us whether we have a function that looks like this or a function that looks like this. So slowly taking off versus quickly taking off. And with this knowledge, let's see what kind of shifts and translations we have with this function that they gave us. So coming back up here, graph this function. Let's kind of just look at what we have so far. We have our base, 2, a horizontal shift. Horizontal shift is directly next to our input. So +2, this tells us negative, not +2, negative, +1. So it tells us that we're moving left or in the -1 direction. So left 1 unit. And our vertical shift. Here we have a -3, so up and down. This is going to be down 3 units. So here, left 1 unit. All right, and our base is going to be that 2. And now let's get a rough copy of what our graph normally looks like without any shifts or translations. So here, bring this down a little bit. Here at 0, we're at 1. So we'll say 1, 2, 3, 4, 5, 6, 7, 8. So we're here at 1. At 1, we're at 2. At 2, we're at 4. 3, we're at 8. At -1, so with -1, we have 2 raised to the power of -1, which is 1 over 2 or 0.5. Here at -2, 2 raised to the -2 is 1 over 2 squared, which is our 1 over 4. And here at -3, 2 raised to -3, 1 over 2 cubed. 1/8. So these numbers are again getting really, really, really close to 0, but never actually touching. So 1, 2, 3, 4, 5, 6, 7, 8. So this here is what we're comparing our graph to. Now our graph here is being shifted left 1 unit. So all of these values are going to the left 1. So left 1 unit here, left 1 unit here, left 1 unit here, left 1 unit here. But also going down 3 units. So down 1, 2, 3. Down 1, 2, 3. 1, 2, and 3. So let's remove these here. And let's see what numbers would actually get us a better idea of what our graph is doing. So if we grabbed this one, shifted it left 1 unit. So instead of using the numbers -2, 1, 0, 1, 2, we're shifting them left 1 unit. So starting with -3, those are going to be our inputs. So going further left, we're starting with -3, -2, -1, 0, and 1. That still gives us 1, 2, 3, 4, 5 points. It looks like we should be able to graph our function based off of those 5 points. And we could use a calculator if you really want to. So here's our graph. All right, starting with -3, we have 2 raised to the power of, starting off with -3, and we're adding 1, so +1, close parentheses, and bring the cursor down, -3. That's that first one. So that's -2.75. And we could copy this. Next one we're going to look for is -2. So -2 is a -2.5. Next is -1. That's -2. The next one is going to be 0. We delete 0. That's -1. And looking at +1. And that ends up giving us +1. So let's graph these and see where we're at. -3, 2.75. Let's graph these in gray. So -2.75, that's -1, -2, -3. So -3, 2.75 is about here. -2 is at 2.5, I'd say about here. -1 is at -2. 0 is at -1. 1 is at +1. So there is our graph. It looks like it's getting really, really, really close to, I'd say, 3. Let's see if we can make any comparisons. If we had this graph right here getting really, really, really close to 0, but never actually crossing it, and we got that graph and dropped it 3 units, so from here down to here, that is our new asymptote. So our new asymptote is going to be y equals -3. So with our domain, let's take a look at our range. And based on that, we could give our asymptotes. So domain is still going to be negative infinity to infinity, or all real numbers. Our range starts here and goes off to infinity. And it starts here, gets really, really close to our horizontal asymptote. Parentheses, because it never actually crosses, it never actually touches the asymptote. And that is at -3, and we go all the way up to infinity. Asymptote again is that y equals -3. And there we go. If you have any questions, please feel free to ask. Otherwise, bye.